Now, we're going to take up one more problem on shaft. The problem number 8, it reads as a solid circular shaft has 40 mm diameter. When a twisting moment of 1 kilonewton meter is applied, determine the shear stress induced at the center at a point 10 mm from the center and at the outer surface. Also, draw the sketch showing the distribution of shear stress and discuss about the result. So this is the problem given to you. So first, the diameter of the shaft is given as 40 mm and the twisting moment, that is the torque, is 1 kilonewton meter. So that will be equal to 10 to the power of 6 Newton mm. So that means 1 into kilo is converted into Newton, that is 10 to the power of 3. A meter is converted into mm into 10 to the power of 3. So 10 to the power of 3 into 10 to the power of 3 will going to become 10 to the power of 6 Newton mm. So now the relationship between the torque and shear stress induced in the solid circular shaft, which is given by T by tau, will be equal to Jp by R. So we need to have the shear stress at the center of the shaft first. So when you are considering the center of the shaft, tau will be equal to T into R by Jp. So what he says, he wants to know what will going to be the shear stress at the center. So that means when the radius will be equal to 0, what happens? The shear stress will going to become 0. And similarly, when the shear stress induced at a point at 10 mm from the center. So that means you have a radius of 10 mm. What will going to be the shear stress? So tau will be equal to T into R by Jp, which is equal to 10 to the power of 6 into radius is 10 divided by Jp, pi by 32 into 40 to the power of 4. Therefore, the shear stress will going to be 39.8 Newton per mm square when it is at a radius of 10 mm from the center. So next will be shear stress induced at the outer surface when R is equal to 20. So again tau will be equal to T into R by Jp. So that will be equal to 10 to the power of 6 into radius is 20 by pi by 32 into 40 to the power of 4. So therefore, which will be equal to 79.6 Newton per mm square. So then where R will be equal to D by 2, which is 40 by 2, which is equal to 20. So from the figure it is concluded. So what the figure says? When the radius at the center is 0, the shear stress will be 0. When the radius at the distance of 10 mm from the center, it will be 39.8 Newton per mm square. When the radius is 20, that is from the center, the shear stress will going to be 79.6 Newton per mm square. So therefore, how to conclude when the shear stress induced at a point is linearly related to its distance from the center, which is linearly related. That means it is increasing by exactly by 2 times. So therefore, the shear stress induced is maximum at the outer surface of the shaft and it is minimum, that is 0, at the center of the shaft. So this is how you will be able to analyze this problem and solve this problem. Thank you.